Welcome to my channel. Your tutor Mariam is here. It's the 51st video of Introductory Physics 1 and the 13th video. I'm going to talk about the laws of motion. That is the fifth subject of Introductory Physics 1. In this video, I'm going to solve another example that I find it interesting about the normal force. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like the bell. You ready? Let's get started. Let's see what I got. A box with a mass of 2000 grams is moving upward with a total acceleration of 4000 millimeter per millimeter second square. What's the normal force acting on the object? So here I have a box moving upward. Total acceleration is 4000 millimeter per millimeter second square. And then I need to find the normal force, right? So normal force direction gonna be upward, and also we know that there is a weight applying to the object, right? So that's gonna be m times g. So if I write the second Newton's law, total force gonna be sum of the force applying to the object. So we know that is gonna be n minus mg. Remember, if this is my original, my x direction, this way gonna be positive, and if it is go upward, that's gonna be positive too, right? So that's telling me my n here gonna be positive, my w gonna be negative, correct? And then it's gonna be equal to ma. What you usually see in the physics problem is the total force, not the total acceleration. So if you have a total force, you can simply apply that total force here, right? Because ma is a total force. But here I have an acceleration that I need to apply. So from here, my normal force gonna be mg plus ma, right? So that's gonna be ma plus g, correct? My motivation I have for solving this problem for you is the units here. I want you guys pay attention to the units. So mass comes with the grams, and acceleration is in millimeter per millimeter second square, right? So if you look at the second Newton's law, F m times a, the unit of m mass must be in kilograms, and the unit of acceleration must be meter per second square, right? So if you don't have that units, you must do the unit conversion, otherwise your answer is wrong. Okay, so let's start with mass. Mass must be in kilograms, right? What I have here is in grams. So let's do the conversion from kilograms to grams, grams to kilograms. So 1 kilograms equal to 1000 grams. Okay. So let's do the conversion. I have 2000 grams times grams, kilograms. 1 kilograms equal to 1000 grams. And if I do the math, remember this one is in denominator, so it's going to be cancelled out with this, and that's going to be 2 kilograms, right? If you don't know how to do the unit conversion, I solved it in the previous videos. I'm going to put the link below. Feel free to check them out. So now I have mass as a kilograms. So let's do the unit conversion for acceleration. So 1 meter is equal to 1000 millimeter, right? And 1 second is equal to 1000 millisecond, right? So if you look at these two equations, you will see the prefix of both of them is in milli. So when we talk about the milli, then it should be 1000, right? That's a prefix. I talked about it in the previous video. As I said, I'm gonna put the link below so you can check them. So then I have 4000 millimeter per millisecond square, right? Times. Now I need to put the units in terms of that millimeter gonna cancel out. So that must be in denominator, right? Then these two guys gonna cancel out. And then meter should be in nominator. So 1, and then that's gonna be 1000. Remember, 1000 is close to millimeter, right? So that's gonna be millimeter, and this guy right here is millimeter. So 1 meter right here is equal to 1000 millimeter, right? And then for the second part right here, for a second, that second gonna cancel out, right? So that's millisecond square must be on top, right? And the second must be in denominator, correct? So 1 second, look at here, 1 second is equal to 1000, right? There is a trick here. Remember, this units, it's second square, right? But what I have here is second, right? So that square must be applied here. So that's gonna be a square of that, correct? So now if I do the little math, then my answer gonna be, right? And then the other way I can write it is like 4 times 10 to the 6, correct? And that's gonna be my final answer for acceleration in meter per second square, right? Now I need to find the normal force right here. So far I calculate the mass and acceleration. Now I need to find the normal force. So this is the equation I ended up. I found mass as 2 kilograms, right? We know that acceleration is 10. So it's 9.8 meter per second square, but approximately 10. So I'm going to assume this is 10. And acceleration I found is, then it's going to be 2 times that guy. So it's going to be approximately 8020, right? Which can be said approximately 8 times 10 to the minus 6. Approximately, if we ignore that 20 part right here. So that's going to be in newtons. I hope you find this video interesting. If you like my video, hit the like button and subscribe. And I'll see you in the next video.